Let's get started. The year is 2007. I was writing Visual Basic code at the time, and I wanted some place online to share pieces of code. GitHub did not exist back then, and so I figured I'll build it. My grandfather was working with PHP, building small websites, and he introduced me to PHP. That's how I got into this beautiful ecosystem. What I really loved about it was the accessibility. It was easy to get started, and to host stuff, you just put it on a shared server, and it runs, and it's accessible because it's simple, but also it can be cheap to run. Now we are many years later, and I'm interested in serverless because I believe it's really close to that vision, what the web should be, accessible and simple. I'm not saying serverless is perfect and like magic, but I believe there's that vision, and that's why I'm interested in that technology. So I will talk about AWS Lambda. You can run serverless, you can use serverless or whatever on different cloud providers, but today if you want to run PHP serverless, I would recommend going with AWS Lambda because it's like it was the leader when it launched. I believe it's still the leader today and the most reliable option you may have. Yes, even for PHP, Lambda does not support running PHP, natively at least. They have a concept called custom runtimes, and we can add support for PHP. So you have three options if you want to run PHP on Lambda. You can build your own runtime, compile PHP for the Linux version that is on Lambda, and write a bunch of code. I've done that. I would not recommend it. It's a lot of work. So I would forget about that. Then you have Bref, which is an open source project that provides the PHP runtime for you in a mechanism like that is officially supported by Lambda. And you also have another option, which is called Laravel Vapor, which is a paid product that lets you run PHP as well on Lambda, specific for Laravel. Vapor and Bref share the same roots and the same solutions, so what I will talk about today can apply in most cases, I would say, to Vapor as well. So I will talk about how PHP runs on Lambda, basically. Bref is an open source project that I created 8 years ago. It has grown since. It used to be very hacky, very weird, very don't use it in production, but it's been some time now. Sorry. And it's used across many different companies to deploy many different kinds of applications, and it's handling a lot of traffic. Functions or applications, this is how we deploy on Lambda. We'll see about that. But you can see how much across all usage there is. We have crossed 40 billion invocations, so these are requests, jobs, cron tasks, whatever, across all users. So what I'm trying to say here is that if you've seen Bref in the past, it's a bit different now. It's now kind of a boring technology where it works and it's safe to use in production. I will talk about how it runs, just a quick intro on how you use it, because the goal of Bref and all of this and serverless is to make things simpler. So how do you use it? Very quickly, a serverless.yaml file in your project, and in there you describe what you want to deploy to your AWS account. So you don't have to go click, click, click in the AWS console, which is very scary. Anyway, here I'm defining a function. A function is kind of like a container, right? So I have a web function for a web application, and I could have a separate function for the cron tasks or the queues. But I have a single function, and it runs. That contains all of my app, whether it's a Symfony or Laravel app, and I point everything to public/index.php, just like on any server. That's where all the requests go, and then the framework does its magic. URL true, this is because it's a web application, I want a URL, and you have to ask for it. You could deploy queues and whatever, and you don't want a URL there. Then you deploy with the serverless command, serverless deploy, and it gets deployed into your AWS account, configured with everything. If you know a bit about AWS, under the hood, it uses CloudFormation, which is kind of AWS best practices. It's like Terraform, but for AWS. Very solid, very robust. You just don't have to deal with the complexity with that command. Now I want to show you with a demo, not how you use it, but how it runs. because I believe like show, don't tell works a bit better. And now we have to pray that the Wi-Fi actually works. It's not guaranteed at all, so I will need your help. What I've done is I've deployed a very simple application. So what I've shown you before is like the simplest example, of course. You can add databases and custom domains and everything. I just kept it simple. I created a simple app. I've instrumented it with very hacky things, and we're going to see it scale. So what I want you to do is scan this, and hopefully we should see the application scale up. Oops, sorry. There we go. We can see some gray bars and some blue bars, right? Let me move around. Every blue part, this is nice to be able to come up close to it. Every blue part is a request. I added a slip in there so we can see those requests. And the gray bars, the horizontal ones, are like containers or servers. We went from 0, so I deployed, nothing was running, and we went from 0 to maybe there are 8 or 10 of them. We can scale up. I have, we can run A/B. If anyone wants to hammer the server, you can do that. Not really the server, but you can refresh, you can hit the emoji, and we can try to scale it up as much as we can if we, yes, thank you. We can see a few different things. So the scale-up is instantaneous. Containers start instantly with the traffic. One thing to understand here is that one container, one gray bar, handles one request at a time. Usually a server or a container handles many requests, right? Here, that's not the case. One container handles one request at a time, which is very similar to how PHP runs with FPM, right? Which is kind of ironic that Lambda does not support PHP, right? Because they kind of copied this execution model. But we don't care. What matters is that it works, it runs, and we don't really have to think about it. I did not do anything, it just works. And over time, the unused containers, like these ones, will just be garbage collected by AWS Lambda. Thank you. No. OK. How does it really work? I want to go back to the beginning. I deploy the application. Nothing is actually running. That's what we saw. There were no gray bars, no containers. I should call them instances. Using the word container is kind of outlawed in the AWS Lambda world, but I think it works fine. When we deploy something on Lambda, the only way to execute the code that we deployed, whether it's a Symfony, Laravel app, or just a simple script, to invoke it, we have, I use this, we have to call the, no worries, there you go. We have to call the AWS Lambda API. The AWS Lambda API is a public API like the GitHub API, Stripe API, whatever. You have to use AWS credentials, so access keys, and you invoke it with a post thing, and you pass a JSON payload, and that's how your code is triggered. That's event-driven. OK. That is, we don't want that. We want a web application, right? That's OK. That was the URL true was about. Because with URL true, we actually have, like serverless will deploy for us a web server, which is either Lambda function URL or API gateway or other AWS services like load balancers or whatever. We have different options. The idea here is that we are composing AWS services together so that the one on the left receives the HTTP request, has the custom domain, has everything you can imagine, and it turns that invocation into, like that request into an invocation of your function. This is really about the idea of composing AWS services together. And that's how every AWS team works on solving one small problem at a time. Now, if we look at the invocation, the payload is a JSON payload that looks like this. And this is very specific to AWS Lambda and API gateway, by the way. If you were writing Node or Python in Lambda, you would have to handle that. In PHP with Bref, we don't have to, and I'll get there. But this is the JSON payload. Now, when the first request comes in, Lambda starts a container or an instance on the fly. When we deploy our code, so where is that instance running? When we deploy our code, we choose an AWS region in the world. Whether it's Frankfurt, whether it's in Ireland, in the US, whatever, this is where our code will run. But actually, when we select a region, like here, Frankfurt, we select a set of data centers in the city. There are always multiple data centers in one region, in one city. We are not supposed to know where they are. This is secret. However, WikiLeaks provides us with some maps, so I just put it out there. Who cares? The main thing to keep in mind is that our code is deployed somewhere, and if we were to run a server, it would be in one of these data centers, in one room. If the data center is flooded or burns, we lose our server. With Lambda, the instances are load balanced across all of these data centers. So out of the box, we get redundancy hosting and self-healing, which is pretty nice. But yes, the instance runs on a server. Serverless runs on server. More specifically, AWS Lambda runs on EC2. Again, the AWS teams like to reuse the services provided by the other teams as building blocks. AWS Lambda runs on instances like servers, bare metal servers, called M5 Metal, that have a lot of CPU and RAM and huge servers. Who cares? I don't care about that. It's just that on one server, there are like thousands of Lambda instances. We only get a fraction of that for our code. And you're thinking, yeah, virtual machines, or yeah, containers. Not exactly. It's something in between called Firecracker. That's a technology that is open source, that has been created by AWS originally to run AWS Lambda instances and get the best of both worlds. Like the strong isolation from virtual machines for network access and like even CPU and RAM, but also the lightweightness or the fast startup from containers. So you get both of those into Firecracker, and now it's used by other cloud providers as well. It's getting popular, and it's called the micro VM. I'll call them containers, it's simpler. But who cares? It's a Linux machine. So whenever the Lambda instance starts, you have a Linux machine that starts. And in there, the runtime is being mounted, just like your application. Now, I'm saying mounting and downloaded, it's actually extremely optimized. There are many caches and local caches involved. Just like starting the micro VM, actually. I said the fast startup of containers. A micro VM starts in about 100 milliseconds. All of that time is actually not really visible in your applications because these instances are booted out of the request cycle. Lambda maintains a pool of warm VMs, micro VMs, ready to be used for your application. The download part as well, sometimes Lambda will anticipate that you have traffic at this specific time of day, and they will download and mount the thing and start your instance in advance. Not all the time, though, and I will get back to that. So anyway, the instance starts, and one program in particular starts. That's the runtime API. That's a Go program, and if we look hard enough on GitHub, we can find a source code for that. And what it does many things. But one line in particular, or a few lines, are interesting. That's an exec call to a file called opt or opt, I don't know how to call that, bootstrap. Anything in that directory is from the custom runtime. That's where the Bref files are mounted. If you were using an official runtime like Node or Python, it would be the same thing, same file, same mechanism. So Bref has to provide that file. And if you look in the Bref repository on GitHub, this is what you get. It's an infinite loop, so that if anything crashes or seg faults or whatever, it doesn't really happen, but if that happens, PHP starts again, but that's starting Bref, essentially. So it's starting a PHP bootstrap file, which looks like this. It requires the autoloader and starts Bref. what does Bref do when it starts? It calls back the runtime API. Why? Because, as I said, it's a Go program, but it's called the runtime API. It's exposing an API locally inside the Linux instance. It's not accessible from the outside. It's just localhost. It's very fast. And Bref calls it to actually retrieve the JSON payload of the request we need to process. So it's not Bref being told what to process. We have to fetch it. It doesn't really matter. I'm just explaining that's a design choice that they made because they wanted to offer support for all languages. And if you want to support COBOL or Bash Lambda functions or whatever, what's the the lowest common denominator across all of these languages? It's not really starting up a server. That can be hard in Bash. However, doing an HTTP request with curl or whatever, that's something you can do in most languages. So that's why they went with that pattern. OK. A bit weird, but OK, that works. So then Bref has the JSON payload. What it will do, it starts FPM and turns the JSON payload into a normal standard PHP FPM request called FastCGI protocol. FPM is a binary officially provided by PHP, and that's how you most probably run PHP today on servers. You have Apache or Nginx receiving the HTTP request and turning it into a FastCGI request. PHP FPM runs your code, and on Lambda, the same thing happens. Bref is like translating stuff. And your code runs just as usual, like on any server in Lambda. Now, you may be thinking that's lots of steps and conversions, right? Who cares? Who cares because it's working, and it's pretty fast. The whole conversion request, I benchmarked that. It's less than a millisecond. You have some network involved on the left side because you have different data centers. When you have a load balancer, you know that network time is incompressible. So you lose about 10 milliseconds because of the distributed aspect of it. But here, it's negligible. So I've considered multiple times rewriting Bref, that part in Go or in Rust or as a PHP extension, Franken PHP, and all of these. But yeah, it works. So at least everyone can contribute. Now we have one instance. PHP runs Laravel or Symfony or whatever, returns the response, and it goes back the same way. Let's get back to the execution model. So I mentioned one instance handles one request at a time. So when Bref starts PHP FPM, for those who know, it will start FPM with just one worker because we don't have concurrent requests. One thing to note as well that is really interesting here is that whether we have one request on the website or 1,000, every time our code runs, it runs in the same environment. We never have to think about concurrency, about is the memory full, is the CPU being overloaded by all of those concurrent requests. It's always the same thing. It's more of the same, essentially. It's crudely simple. And we are only limited by how many containers Lambda can start, and it can start loads of them. So that's why we have huge scalability here. Of course, if we hit up a centralized system like a database, you have to think about scaling the database as well and making sure everything handles the expected traffic. But at least here on the code part, you're safe for scaling. Now, something interesting happens between the requests. Because if I say to you, hey, you can scale up to 1,000 containers, and you're like, I already pay for one container or one server. Do I want to pay for 1,000 containers because of people sitting in the audience right there? The cost model is different. I will talk about that. But essentially, between requests, so anything gray here, our code does not run. Our container is actually frozen. We cannot run anything in between requests. Every active process stays in memory, so FPM doesn't restart. The Bref runtime doesn't restart, it's just frozen. That's how AWS optimizes the request, because it knows that it can, it's like a big shared hosting thing, just like the free hosting I mentioned at the beginning, except at a huge level. Of course, we have to talk about cold starts. Everyone talks about cold starts. We have to talk about cold starts. Cold starts is when we have like the first request, or whenever it scales up, we have a new container that's starting up. That's when a request is needed here. And we can actually see here cold start. They, in real life, in production with traffic, they account for about 0.01% of all requests. So they are there. It's a small amount. The question is that small enough for your use case? On the first request, you can account for, on the first request when there's a cold start, because AWS optimizes stuff and keeps some instances in memory in advance. But when that happens, you can account for about 250 milliseconds to 500 milliseconds. In extreme cases, if you have huge applications and you're doing loads of stuff on the beginning, you can have 1 second delay, but usually it's like 500 milliseconds is the worst on larger frameworks. Anything warm after that is like the instance. There is no performance difference once it's warm with any server. Now, one thing I like the way I like to frame cold starts, to think about it, is having a cold start is the worst thing that could happen for users. Let's say you are building a website where people can buy concert tickets, and everyone rushes at the same time to buy the one concert everyone wants to go to. Yes, some will get some cold starts because the website is scaling up in real time. If you had servers, or even if you had scaling and auto-scaling, it takes a while to put more containers, more servers. And so the worst case scenario is that the website is slow for everyone, or worse, it's down. With the Lambda execution model, the worst case scenario is 500 milliseconds extra on some requests. So that's one way to think about this. You can also pay to avoid cold starts, but in most production applications, when I ask around, nobody really cares about cold starts because these are the outliers and they are less worse than the worst case scenario when you don't have that kind of scaling. I mentioned that already. We have self-healing and redundancy built in with the data center thing. When one Lambda crashes completely or the data center crashes completely, well, you lose the request, obviously, but then you just lose one request. Pretty cool. That's out of the box. And let's talk about the costs. And that's really where the freezing thing really comes into play. Essentially, we don't pay for the gray parts. We don't pay for the instances. We pay for the blue parts, for the requests. Which means, let's say you receive 1,000 requests in a month. You will pay for 1,000 requests. If you receive 1,000 requests at the same time with 1,000 containers, like insane scalability, you pay for 1,000 requests. You pay for the same thing. It really changes how you think about costs here. Now you have some numbers to help you get an idea. The free tier is like 1 million requests. So for side projects, it's really great because you can have free hosting. Essentially, it doesn't include the database because obviously you run the database on a different server, or on RDS or whatever. But it's a good start for small websites. And then it's about this cost for 1 million requests that last for 100 milliseconds. You can have like you pay per the request, but also the duration. So if your requests are twice faster, it's twice cheaper. That's another interesting thing to think about. Now, usually people are really worried about how do I estimate my cost, but it actually sometimes is not that hard. You look at last month, how many requests and jobs and cron tasks were executed? Was that 1 million or 10 million? And then you can estimate. What if we grow 10 times what we have? We can estimate very easily. When you have servers, what happens when we grow 10 times? How much will this cost? How many servers will we need? It's harder to say. So with that model, there are some advantages. There are some downsides, obviously, but there are some advantages. There's a cost calculator on the Bref website. You can have a look at that. And you can set up, obviously, budgets for alerts, scaling limits. I set up a scaling limit on my demo to 50 containers. I can set up 1 if I want to, but like 50 for 1 hour, it's like very safe. And one way to like really think about is, what if there's a traffic spike, like a huge traffic spike? Well, again, 1,000 requests over a month is not a lot. But 1,000 requests over an hour sounds like a lot, or over a second sounds like a lot. However, it's the same quantity. So when we look at traffic spikes, for example, when going live on TV or on the front page of Hacker News, it's like 1 million requests, 2 million requests, something quantifiable. We can estimate how much it costs. This TV show in France is famous for crashing the websites of companies that go live. That's less than $2 to handle that kind of traffic. Again, I'm not saying I would love to be on the receiving end because so many things can go wrong, but just to give an idea that it's not really about the traffic spike. It's about the total sum of requests you have in 1 month. With Bref, you can handle non-HTTP events as well. I talked about a lot about HTTP and FPM. This is one way to run PHP in Lambda. That's called one runtime, the FPM runtime. You have another runtime for non-HTTP events. That lets you do pretty cool things, like when there's a S3 event, like there's a new file, please invoke my code, or SQS for queues, event bridge for, that's an event bus, so event-driven microservices, and you can go on. There's a huge list of services. So again, we are composing. These services integrate with Lambda natively, which means we don't have to write a long-running process that connects to SQS or monitors files. We just get notified. Again, event-driven, which is scary when you say the word, but when you look at it, it makes sense. There's a new job, trigger my code. I don't have to run the daemon thing. So again, these will invoke Lambda, and this is a function for, let's say, SQS, it's a queue. Bref here is not running FPM. It will execute my code directly. Here is what it looks like for an S3 event. Let's say a new file is created. I can handle that file directly in my code with a class. Those classes are provided by Bref. Here's the same thing for SQS. If you want to do a job queue, you create the queue, you create the class, you can handle the jobs, throw exceptions, they will be retried. Here's how you set it up in serverless.yaml. That will create a queue, that will create the worker and call this class. Now, like Bref integrates with your frameworks, Symfony, Laravel. You can also create an integration with your custom framework so that you can get dependency injections in your classes. Everything is running as usual, so you don't have to think about it like a weird thing. That class can sit in your code base and do everything as usual. Of course, these classes are tied to AWS, to Bref, but Bref provides integration for queues. So if you're using Laravel queues or Symfony Messenger, essentially there's an integration with Bref, and it just works. You can use Laravel queues, push a job, it goes to SQS. You have to set SQS as the driver. And then instead of thinking about, I need to run the worker now, you don't have to run the worker. You just create the worker function, which is, if you look in the Bref docs, you just copy-paste. And the SQS will invoke the Laravel class or the Symfony class to trigger your job. It also means that with that scaling model for job, it's extremely interesting because you can think about, oh, I have 1 million jobs to process, or let's say 1,000 jobs to process. You can process them one at a time with a scaling limit of 1, and you pay for 1,000 jobs. Or you can process 1,000 jobs in parallel in like a second, pay for the same thing. For jobs, it's really interesting. There are integrations as well for Laravel Octane that runs without FPM, for the Symfony runtime as well that runs without FPM, so you can keep your kernel warm and avoid the bootstrap of Symfony and Laravel. That works. You don't need Spool or Roadrunner or whatever because it just works natively with Bref. And that's about it. That's the how it works and what you can do with it. How it works. Let's talk about what you can do with it, because at this point, maybe you're thinking, oh, that's less exotic than I thought. Which kind of project would be best for serverless and Lambda and Bref? That's a question that is hard to answer. So instead of giving you a generic thing, I will give you some examples of applications running with Bref in production. And I want to start with a very simple use case, like side projects. This is my blog. There's not a lot of traffic, less than 1 million requests per month. I don't need the database because it's all static. It's really fast. It's a Symfony application, so it just works. I forgot about it, and it's just running, and it's free. Pretty cool for small projects. What about larger projects, commercial ones? I have many examples. This is just one. Bcast.fm is an app that is running Laravel on Lambda with Bref. It's been 5 years now. They handle quite a bit of traffic every month, and they are pretty happy with it. They don't have to deal with infrastructure and server management. So even at these kind of traffic, that works out for them. Another example, this is a very famous newspaper and news website in France. So if you go on the website, this is publicly facing, right? They don't care about the cold starts. I mean, they care about the cold starts, but it's not preventing them from using that in production. The website, you visit that and you go through Bref API proxy. I don't know how to call that, but it's running through Bref. What about larger websites then? Sua Musica is like the Brazilian iTunes in some sort. They handle 1 billion requests every month. This is a huge website. They run on AWS Lambda, and they actually migrated from EC2. They migrated to Lambda and saved money on the AWS bill, which is interesting. I bet they saved even more when you consider the effort and time and salary of the people involved in maintaining the EC2 instances and everything. Because with Lambda, you have less work to do. But even just on the AWS bill, they managed to save money. Now, what about, do we need to use AWS like crazy? What about legacy applications? Here's a good one. Trezor is a bank as a service platform. They handle credit card transactions, like you go to a store and you pay with the credit card and it calls the Trezor API and it runs with Bref. They actually had a legacy PHP application, PHP 7.4, on servers somewhere, I don't remember where, it wasn't AWS. They moved the legacy application into a single Lambda function, like the whole monolith. They called that a bank in a Lambda, and it worked. They did a lot of tests, right? Of course, it took a lot of time, but it worked. By doing that, they had better response time, they had less work to manage servers, they had less incidents in production, and then they were able to split that legacy application, that monolith, into multiple microservices by doing advanced routing with API gateway, and split all of that into microservices, and then go crazy with AWS SNS and Eventbridge and whatever. What I find interesting here is that first, if it works for a bank, right? If it works for live credit card transactions, that's a sign, but also the legacy part, the monolith part, and the microservice part. I see very different use cases, like applications of Bref, where you can actually run legacy applications or monolith and stop there, and it works really well. If you just want hosting, hosting is not a bad word. AWS Lambda is perfect hosting platform. If you want to go microservice architectures, event-driven stuff, you can, and you can use whatever AWS has to provide. You don't have to go all in. You can make the choice. So am I saying serverless is for everyone? No. I think it's more complex than that, and it's less dependent on the project itself and more on the team and the people involved. I have good friends, they are really good at Docker or at Kubernetes or at managing servers. And if the infrastructure works well, you don't have to change it. You don't have to solve a problem that doesn't exist. Serverless is not for them, and that's perfectly fine. I think serverless is interesting for developers that will struggle with the migration to the whole cloud thing, to the whole one-to-n migration, where you may start with one VPS, one server, and honestly, it just works, and that works well. But maybe there comes a point where you need more than one server or one container. Maybe you want to scale up horizontally. Maybe you want redundancy, because you cannot afford the website to go down if one server crashes. Maybe you want a self-healing aspect. Maybe you want to automate your infrastructure for disaster recovery, for staging environments, for multi-tenant hosting. Like, going one-to-n, there are many different reasons to do it, but it's a hard one. Because you have to think about, oh, I need to store the logs in a central place. I need to store the sessions in a central place that is no longer the file in the server. I need to move the database to a centralized server, and maybe think about redundancy as well there. The files like the uploaded files or the generated CSV and PDFs, I have to store them, again, somewhere else, like S3. That is the migration. It is not specific to AWS Lambda. It's a migration that is specific to distributed architectures or hosting. And I believe for those scenarios, serverless is an option. So you can learn about server management and go auto-scaling and configure things yourself, and that's fine if that's what you want to do, and that's where you want to spend your time. You can go Kubernetes, and you can go many different options. All of them are fine. But for some people, they don't want the investment, or rather, they want to lower the investment. They want to get coding and things to just work. Serverless is not magical, but I believe serverless is like a very good option for those teams. Now, if you want to get started, I have a story. I mentioned my grandfather introduced me to PHP almost 20 years ago. Sadly, he passed away recently, and while cleaning the house, I found floppy disks. And I figured, I don't want to throw them away, but what should I do with it? So Bref is open source. And if you want to live and try Bref at home, you can grab Bref on a floppy disk. I have many of them, so you can grab one. If you do use Bref, keep your dependencies up to date and grab one as well. If you have the chance of having internet at home, there's the website. I do have one more thing, though. I started Bref 8 years ago, and it's been a roller coaster. It's been the best thing I've ever done, I think, in my life professionally. And I've always wanted to make it sustainable. I want to work on Bref for the next 10 years. I need to find a model that works with that. So 1 year ago, even more than 1 year ago, actually, I started working on a new project called Bref Cloud, which is a paid product meant to help get started with serverless even faster and make it even simpler so you don't have to mess with AWS. Now, this is not an ad. I will not stay on that too long, just mentioning I'm launching Bref Cloud today, right now. And while I was talking, the tweets went up. So I'm really happy to share that moment with you and finally ship that project to production. So if you want to check it out, Bref Cloud. Thanks.